Welcome to the Deep Dive. This is where we take the sources you send us, dig in, and pull out the key insights. Think of it as your way to get informed quickly. Maybe find some surprising stuff along the way. Today, we're heading into some, well, pretty unconventional ideas. It's a concept called motion theory, and it suggests a whole new way to look at starlight and the heliosphere, our solar system's sort of extended bubble. And the sources you shared, they definitely challenge the mainstream scientific view, which, always makes things interesting for us.
Absolutely. It forces you to reconsider the basics.
So our mission here is to really try and grasp what motion theory is saying about stars, about the heliosphere, and what that implies about, well, reality itself.
Yeah.
And it kicks off with a really bold claim. You weren't seeing ancient starlight. You're resolving real-time structured motion.
That's the hook, isn't it?
Yeah.
It grabs your attention straight away.
It really does. Okay, so let's unpack that. What's the foundation here?
Well, the absolute core of motion theory is this idea that everything is built from motion. Not just any motion, but structured, rhythmic patterns. So light, gravity, even time, energy, life itself. It's all seen as these elaborate motion patterns.
Okay, so forget particles zipping across space.
Pretty much. The theory argues nothing travels across space as, an isolated particle or photon. That whole picture is replaced.
Replaced with what exactly? You mentioned patterns.
Yeah. Reality is described more like a vast interconnected web. A web of what the theory calls sync loops and coherence gradients. It's constantly evolving, constantly adjusting.
A web. Okay, like a dynamic tapestry instead of empty space with bits flying through it.
It's a good way to think about it. It's about interconnectedness and rhythm, not isolation.
So, if there are no particles traveling in the usual sense, how does motion theory explain something fundamental like gravity or light? We certainly experience those.
Right, it has to account for them. And it does, but differently. Gravity, for instance, isn't just about mass warping space-time. It's described as convergence toward higher sync density.
Higher sync density meaning?
Imagine regions where this rhythmic motion is more concentrated, more synchronized. Other motions, other patterns get drawn towards these denser sync areas, sort of like how planets orbit a star.
Okay, so it's about the intensity of the rhythm, the synchronization, and light. How does that fit in?
Light is understood as structured motion collapse. It's not a thing arriving at your eye. It's more like a specific event, a resolution happening within this underlying motion substrate.
A collapse or resolution. But how does that connect to seeing, say, a star that's supposedly millions of light years away? My gut feeling is something traveled that distance.
And that's the paradigm shift. Motion theory says your eyes aren't just passive buckets catching old photons. They're described as biological motion detectors, active detectors.
Active? How so?
They actively lock onto and synchronize with these rhythmic patterns that are already present in the motion substrate, as the theory calls it. So when you look at a star, you're not seeing its past state from whenever the light left. You're synchronizing, in real time, with its current structured motion field. Whoa. Okay, so if I'm seeing a star, it means its sync structure is active right now.
Exactly. And the flip side is?
If the star suddenly, ceased to exist, its sync structure collapses.
Then you'd stop seeing it. Instantly.
Instantly. Not millions of years later.
According to this theory, yes. Instantly. Because the pattern you were resolving would no longer be there to resolve. There's no stream of old photons still on their way.
That completely changes the nature of observation.
It does. It shifts vision from passive reception, just catching whatever arrives, to active resolution. Your biology is engaging with an ongoing present reality.
Revolution, not reception. I need to sit with that one for a bit. It's fundamental. It is. And this idea, this framework, it extends beyond just starlight. It also offers a different view of our own cosmic neighborhood, the heliosphere.
Right, the heliosphere, usually pictured as this giant bubble, right? Blown by the solar wind, the particles streaming from the sun.
That's the standard model, yeah. Particle bubble. But motion theory sees it differently. It describes the heliosphere as a stretched, structured motion field.
Okay, unpack that. Stretched motion field.
Think of the sun's own fundamental rhythm, its motion coherence rippling outwards, stretching far into space. It's less about particles being pushed out and more about the sun's underlying pattern of motion extending its influence. Way out past Pluto, apparently.
Forming a kind of shell.
Yes, what the theory calls a sync gradient shell.
Sync gradient. So the edge, the heliopause. It's not a wall where solar wind collides with interstellar stuff.
Not in this view. The heliopause is seen as a sync dominance gradient. It's the region where the sun's specific structured motion pattern becomes too weak, too diffuse, and the background motion patterns of the galaxies start to dominate. It's a handover of rhythmic influence, not a physical boundary of matter hitting matter.
Okay, so there's a spectrum then. Close to the sun, you have this intense, high-frequency motion that's light, UV, X-rays.
Right, the tight, high-frequency structured motion collapse, as the source puts it.
And as you go further out, the motion becomes, what, looser?
Exactly. Looser, lower frequency structured motion. This is what we might associate with the solar wind or magnetic fields in the standard model, but here it's still part of that same underlying motion field, just expressed differently.
Until you get to the edge, the heliopause, where the sun's specific pattern just fades out.
It decays fully into the galactic motion background. The sun's influence gives way.
So the whole solar system is like a moving island, an island of the sun's specific rhythm in a bigger ocean of galactic rhythm.
A moving island of structured motion coherence. That's precisely the language used.
And it all keeps coming back to this core principle, real-time resolution.
Vision is the synchronization of local structured motion detectors with active rhythmic motion patterns across the substrate.
No particle travel is necessary. That's the key assertion.
It really is. And the critical relationship is between sync and structure.
If the sync collapses?
The structure collapses. You can't perceive it anymore.
But if the structure is still there, still visible...
It means the synchronization is live, ongoing, and your senses are resolving it right now.
Okay, but what about our telescopes? You know, Hubble, James Webb, big ground-based ones. They all see the same distant galaxies in the same spots. Doesn't that prove the light traveled consistently?
That's a fair question. Motion theory offers a different interpretation of that consistency. It argues that the fact different instruments do consistently resolve the same structures actually confirms the existence of stable, ongoing, structured motion coherence out there.
So the agreement isn't proof of ancient photons arriving together.
Not according to this view. It's proof that a coherent motion pattern exists at that location in the cosmic web, and our various instruments are all capable of synchronizing with and resolving that same pattern.
And things like adaptive optics on ground telescopes, they correct for atmospheric turbulence.
Motion theory would likely frame that as correcting for local atmospheric sync distortion, minor wobbles or interferences in the motion patterns close to home, not errors accumulated over billions of years of photon travel.
So the consistency reinforces the idea of a real present structure rather than perfectly aligned ancient particles arriving after eons.
That's the argument. Consistent detection points to a persistent structure being resolved in real time.
Right. So the big takeaway here, the thing you really want listeners to grasp, is that looking at the night sky, it's not like looking at old photographs.
Exactly. Starlight isn't some delayed message from the past. It's an active, living resolution, something happening right now between you and the universe.
And that makes you the observer, not just a passive receiver.
Correct. You are an active participant, a synchronized motion resolver. You're embedded within this huge dynamic dance of cosmic structure, actively tuning in.
So reality isn't frozen light from history. It's living motion, being resolved constantly in the present.
The universe isn't throwing particles at you. It's, well, the source uses the word singing.
They sing it to you.
In real time, through these structured motion patterns. That's the metaphor.
That's just quite a poetic and profound shift. Reality as a real-time song we're part of.
It definitely leaves you with a lot to think about.
Yeah, it really does. Like, what does a universe built on this kind of interconnected real-time motion imply for other big questions? Things like consciousness, or how we even experience time itself. If everything is interconnected motion happening now, what does that mean for our understanding of past and future, or subjective experience?
It suggests a universe that's maybe far more immediate, more entangled than we usually think.
Definitely something for you to mull over. A very different feel to the cosmos.